Okay, so now we're going to do another type of successive ionization energy example problem. And so what we're going to do this time is look for the element out of the three given that would have the highest second ionization energy. Okay, so that means, remember, I1 is the first electron removed and I2 is the second electron removed. So what we're going to look for is some reason why one of these elements would have a much higher second ionization energy than another. Okay, so let's go ahead and find them all first. Okay, and so I'm going to go ahead and just mark them. Okay, so here's scandium, okay, calcium, and potassium. Okay, so they're all together on the periodic table right there. Okay, so now let's go ahead and go through each one separately. Okay, so let's start with scandium. Okay, now, if we were to remove one electron from scandium, okay, and it would lose its 4s electrons first, okay, so is there any reason why that would be particularly high? Okay, so if we remove one, then we'll still have one in the 4s. Remove two, we'll still have another. Actually, we won't have any more in the 4s, but we would have one in the 3D, okay? So, so basically, for scandium, I1 and I2 are not particularly exceptional, okay? So, in other words, there's no reason why there would be a big jump. We're not taking an electron from a closed shell configuration, okay? Now, let's look at calcium, all right? So, and do the same thing. Okay, again, so calcium is going to lose 4s electrons. Okay, and think about the fact that calcium likes to form a 2+ cation. All right, and the second ionization energy, that says that we're taking away that second electron. So the first one, I1 and I2, and the first one and the second one are not particularly exceptional either. Okay, so these are not exceptional, not really high. They're just, you know, they're just an amount of energy that we need to put in to ionize, but there's no reason why it's going to be especially high. So now, let's look at potassium, because you were probably guessing that this would be the one that would have an exceptionally high second ionization energy, and the big question is why. All right, so let's look at, here's potassium, okay. Now, there's a 4s electron, okay, and with I1, we're going to remove it, okay. All right, so now, what electron configuration does potassium have? All right, so if you go over here, and so when we take away one electron, then potassium has a noble gas configuration, all right? And so again, you know, potassium likes to form a +1 cation, but it does not like to form a +2 cation, all right? And so potassium has this nice noble gas configuration, so I2 removes an electron from the core, okay, or closed shell configuration. And so so the second ionization energy for potassium is really high. Okay? So basically, this is the strategy whenever you're looking for, you know, which is the highest, whether it's I2, I3, anything like that. Look for the element where you're taking an electron from the closed shell, from a noble gas configuration. Okay? So you're going to want to look at, you know, as you're removing, like scandium, okay, so we removed a 4s electron, one of them, then we removed another one, and so we would still have 3d1, all right? So, again, nothing exceptional. Calcium, we'd remove 4s, both of them, and we would end up with the argon configuration, so I3 for calcium would be very high, okay? And then potassium, so we remove the first one, not hard, but removing the second one, it's going to take a whole bunch of energy because potassium has a closed shell configuration. It has a noble gas configuration.